Today we are looking at the force, acceleration, and speed of a stone that is thrown upwards with and without air resistance. So let's take a look at the first scenario without air resistance. I want you to focus on the force first. So if the stone left my hand with a certain speed, let's say assuming it left the hand at 5 meters per second. The only force acting on it after it left the hand is the weight. And as it moves up, the only force acting on it will still be the weight. And as it moves further up, it will still be the weight, and so on and so forth. So focus now. The only force acting on the stone as it moves up and come down is only weight. And since F equals to ma, and if the net force is your weight, so your acceleration has to be your g. Therefore, what we can conclude is that at every instant, the acceleration is equals to g, and it is pointing downwards regardless of where you are located at. Next, why is the object speeding up and slowing down at different instants? Now, the criteria for whether it speed up or slow down must be due to the direction of net force with motion. So, for the first portion of the path, it is moving upwards, but the force is acting downwards. So, can you see that because of this, speed decreases? So, force oppose motion, speed decrease. Force in the same direction as motion, speed increase. So over here, I am moving upwards, but can you see my net force is acting downwards? So therefore, speed decrease. And on the other hand, because my net force is acting downwards, and I am moving downwards, so speed increase. But what happens when there is air resistance? Now, something that you need to know is that when your speed is faster, your air resistance will be larger too. And this air resistance has to be opposite to the direction of motion. So assuming we have the same scenario where the stone leaves the hand at 5 meters per second. Now, this will be the highest speed because as it moves upwards, it will slow down. So what are the forces at play here? So you have a weight. This same weight will be at every instant, and the weight doesn't change. However, we have one more additional thing called air resistance. Because this is moving up, can you see that you have a air resistance that is opposing the motion? As you move upwards, the air resistance becomes smaller and smaller until it stops. So air resistance is equals to 0. However, as you move downwards, the air resistance increases and it gets larger as it speeds up. So we come to a scenario where if we are looking at the net force, can you see that as you move up, the net force is adding the two together? So since F equals to ma, Can you see that as you move upwards, your F is not W, okay? In this case, it's AR plus W. Since your net force is larger, your acceleration will be larger too. So in other words, my G value here is more than 10. And as I move upwards, my G value actually gets a bit smaller, but it's still more than 10, okay? Until it reaches the top when air resistance equals to 0, net force equals to weight, and this is the one instant where acceleration is equals to 10 meter per second square. And with this, okay, if you can follow the logic so far, you will also realize that the acceleration in this case will be less than 10. Because why? The net force is actually less than weight. And finally, by the time you speed up to a point where air resistance is equals to weight, your acceleration will be equals to 0. Okay, I hope this clarify the acceleration and motion between a object that is moving with and without air resistance. Thank you.